welcome back to a video series on MAT 1033 Intermediate Algebra. My name is Sean Perry. This is video number 54 in the series, Domains and Solving Rational Equations. The usual technique for solving rational equations involves multiplying by the least common multiple of the denominators. It's also going to be essential that we go back and check any solutions that we have and make sure that they weren't inside of our domain restriction. That is to say, the set of values which would make a denominator equal to 0. These so-called solutions are not true solutions and must be discarded. Now, if an equation consists of just a single fraction or a sum or difference of fractions on each side, we can eliminate all of the fractions at once by multiplying by the least common denominator, which I'll call the LCD. This is your fraction killer. If you don't like fractions, this one trick will eliminate all the fractions in one step. So let's look at an example that first has no variables in the denominator. We have x over 2 plus x over 3 is 5 over 6. What value of x would make this true? Well, it's very difficult to see right now, but perhaps we could guess. Or better yet, we could get rid of all the fractions and make it really obvious. The denominators are 2, 3, and 6. And the least common multiple of 2, 3, and 6 is 6 itself. 6 is the first number that all three of these numbers will divide evenly into. That means it's a multiple of each one, and it's the smallest such multiple. So what happens if I multiply by 6? Well, what we're going to find is that all the fractions will disappear. If I multiply on both the left and right, on the right-hand side, the 6's cancel immediately, and I just get 5. On the other hand, the 6 distributes on the left, and I then reduce. 2 divided into 6 is 3. And 3 divided by 3 into 6 is 2. And so on the left, I wind up with 3x plus 2x is 5. Hey, there's no more fractions. And now it's a pretty easy thing to see. 3x plus 2x is 5x, and 5x equal to x. Well, just dividing on both sides by 5, we get x is equal to 1. Now notice there were no variables in any of the denominators. That means as long as the denominators weren't the number 0, there was no opportunity for them to be 0. So there's nothing left to check here either. The answer x equals 1 must work. That's because without a variable in the denominator, it's real easy to see if any of the denominators are 0. You just look for zeros, right? And if there's no variables in the denominator and none of the denominators are 0, nothing bad could happen or is happening. So no solutions are going to be forbidden. There's no restrictions to the domain. On the other hand, here's an example that has some variables in the denominator. In fact, it's got a lot of them. It's got b's everywhere. So we've got 5 over b minus 7 plus 6 over b plus 6, and then we have 7b plus 1 over b squared minus b minus 42. So this is an expression of rational functions. And what we could do, yes, we could combine these using the methods that we learned from the last video about how to get common bases and all of that. But let's be even simpler about it. We factor to see what the factors of each base looks like. These are just simple bases, but this one is actually the product of those two, b minus 7 and b plus 6. This is very similar to our 3, 2, and 6 denominators that we had before. Because this one is a product of these two, this is going to be our least common denominator. And notice that we have to keep this from being 0, or either of these two from being 0. So the forbidden values for b are going to be 7 and negative 6. If we multiply by this b minus 7 times b plus 6 on each side, it cancels completely on the right. And on the left-hand side, it distributes, and only one of each of these terms cancels. When b minus 7 cancels, b plus 6 remains. We multiply that by 5. b plus 6 canceling, we get b minus 7 times 6. Distributing these out, combining like terms, we could just start to solve for b. We bring our 7b over to this side, and so our numbers over to this side by adding 12 to both sides. That gives us 4b equal to 13, and dividing by 4, we get b is equal to 13/4. Now, the only forbidden values were 7 and minus 6, and 13/4 isn't either of those, so it's a solution. All right, let's jump on into the praxis exercises for the day. Try to solve these equations using the methods that we looked at above. Pause the video at this time and give each one a shot. Okay, let's see how you did. So here, the least common multiple is going to be 24x. The least common multiple of 2x and of 2, 8, and 6 is 24. And as polynomials, we have this extra factor of x. It's not in the 8, but that's okay. We're just going to include it here as well. We take the product of all the polynomial terms. In this case, we only have an x, and this is going to be our least common multiple. When I multiply that on both sides, notice that the x's cancel here, and I get 6 into 24 is 4 times 5 is 20. The 24x distributes. 2 goes into 24 12 times. The x and x cancels. And then we have 8 into 24 3 times. There is no x to cancel, so the x remains. When we multiply 12 by 9, we get 108. 3 by 9, we get 12. Minusing the 108 from both sides, we wind up with negative 88. And dividing by 27, we have negative 88 over 27. That doesn't reduce. It's not our forbidden value, which was 0, because 0 would have made these denominators 0. And so this is going to be our answer. All right, this one looks like a fraction equal to another fraction. We could do cross multiplication here, but I want you to see how that's actually the same as the least common multiple method. The least common multiple of these two as polynomials is just their product because they have nothing in common. When we multiply that on both sides, the 21 cancels here, x minus 2 remains, we multiply that by x minus 6. The x minus 2 cancels here, the 21 remains, and we multiply that by 1. And notice what we have here is exactly the terms you would have from cross multiplication. Minus 2 came up, multiplied here by minus 6. The 21 came up and multiplied here by the 1. We've just included the cancellations. Now, yeah, cross multiplication is a good trick, but this method works for all kinds of fraction expressions, while the cross multiplication works only when you have a fraction equal to another fraction. Okay, so what do we do now? Well, we're going to FOIL this out. Get x squared minus 8x plus 12. We minus the 21 from both sides. We get x squared minus 8 minus 9. How do we solve this when it's equal to 0? We factor, we set each term equal to 0, and we get 9 and minus 1. The only forbidden value was plus 2, because we had an x minus 2 in the denominator originally, was our only variable in the denominator, and these are neither of them plus 2, so they're both solutions. All right, let's do this last one. We have x over 3x minus 9 minus 8 over 1 over x minus 3. Now, 3 times x minus 9, that's 3 times x minus 3 as a quantity, so the forbidden values are 3 for both of these terms, and the least common multiple is going to be this guy here, which is 3x minus 9. I've just factored it. That's because x minus 3 goes into 3x minus 9 as a factor. It's one of the factors of this denominator. So in other words, all I have to do is multiply 3x minus 9, or 3 times x minus 3 as a factor, on each side. They cancel completely on this side, cancels to a 3 remaining. So we're going to put a 3 there. And over this one is this term, right? So it cancels to 1 and we just get x. This one distributes to the minus 8, and then we start simplifying. We have 8 times 3 is 24. We distribute the 24 against both terms. We get x minus 24x plus, because minus 24 times minus 3 is positive 72. That's equal to 3. We bring that 72 over, get 69, negative 69, and dividing off our negative 23 when these combine by like terms, we wind up with x is equal to 3. Cool, we're done, right? No, that's a forbidden value. Remember we said no x's equal to 3's. The domain was all of the x's except for this one. This isn't a valid input. This would have caused us to divide by 0, and since the only possible solution was x equal to 3, that means that there isn't actually any solution here. There is no solution. I've included a quick Desmos graph to show you what that looks like on the graphs. Remember, when we have two equations, like here I have the equation that was on the left and the equation that was on the right, when are they equal to each other? Well, when these two y's are equal to each other, which means that these two lines or curves would intersect. But as you can see, they don't intersect. They start to hug closer and closer to this vertical asymptote at x is minus 3, but they don't actually ever intersect with each other. And because of that, because there is no intersection on this graph, this goes hand in hand with not having a solution, which is what we found when we tried to solve this algebraically. Okay, that's going to be it for this video. Thank you very much for your patience. Have a great day, and good luck with your studies.